Robot designs are getting better and more capable all the time, and this is essential for the future of space exploration. If you think about how much work goes on every day aboard the International Space Station, or ISS, it makes sense that NASA is developing specialized robots to help reduce the workload on the astronauts. Systems like Robonaut 2 are already aboard the ISS and are starting to demonstrate their potential and value. Join us as we discover how scientists at NASA Ames Research Center are working on the next generation of remotely controlled robot systems for future space missions. To tell us more about their plans for robotics, we're meeting with NASA Human Exploration Telerobotics Project Manager, Terry Fong. So Terry, what exactly is the HET, or Telerobotics Project?
The Telerobotics Project is all about looking at how remotely operated robots can improve future human deep space missions. It's a project we're doing here at NASA Ames with our partners at NASA Johnson in Houston and the Jet Propulsion Laboratory in Pasadena. It's really important to develop these robots because we're trying to find ways of improving human productivity in space. We want robots that can really work before, in support of, and after humans, and we're trying to find ways of doing this that really allows humans and robots to be a productive team.
Could you tell us some examples of the types of jobs these robots do?
We want to try to use robots to do those things which are very repetitive or very tedious for humans to do. So, basic chores, for example, onboard spacecraft, in terms of monitoring experiments, in terms of just doing routine maintenance. These are the kind of things that robots are really good at because it requires a lot of repetition or precision and things that fundamentally for you and I, as humans, very unproductive.
What are some of the different types of robots you guys are developing?
In the Telerobotics project, we're working with a wide variety of robots. At NASA Johnson, for example, we're working with Robonaut 2, which is a two-armed humanoid robot. It's able to reach out and pick up things just like you and I can use our hands and arms to move things around. Here at NASA Ames, we're working with the Spheres robot, which is a volleyball-sized free flyer that can fly around inside a spacecraft, carry cameras or other sensors, and do mobile monitoring tasks.
So Terry, what's next for the project?
We have been doing a lot of work with both Robonaut 2 and Spheres on space station, but these are still in the experiment stage. Where we'd really like to be, and we hope to be within the next year or so, is at a point where these robots become not just experiments, but really tools, and maybe even beyond tools, as actual partners. So they're working day in and day out to help humans be more productive in space. And for me, that's really what the future of space exploration is, humans and robots working together.
To tell us more about that unusual volleyball-sized robot being tested on the space station is NASA Ames Spheres Engineering Manager Mark Masiri.
This is the Spheres. It was originally developed by MIT, and it flew up to station up in 2006. Spheres stands for Synchronized Position, Hold, Engaged, and Reorient Experimental Satellites. It's used for testing navigation and other guidance algorithms on space station.
How does Spheres work? What does it have inside of it?
It's all fully self-contained. It has its own thruster system, computer system, and then ability to figure out where it is on station. Inside, it has a small digital signal processor, so it's like a small CPU that helps it do all of the calculations it needs to figure out which thrusters to fire and how to get from point A to point B. It also has an ultrasonic beacon system, and the ultrasonics allow it to figure out very precisely where it is and what its orientation is.
That looks like a cell phone. What function does that serve?
For this particular project, we're using a smartphone to control the sphere. We were able to use the phone because it gives us a good processing power. It has lots of sensors, it has a camera, and it's very easy for us to write software that'll be able to run on the phone and then control the sphere. The hope is that ground would be able to create a plan of the things that they want the sphere to do. That plan would be uploaded to the smartphone. The smartphone then would monitor the progress of the sphere as it moves through station and execute those tasks. The real benefit is it's able to do this without crew needing to attend it.
What's in store for the future? How do you see the goals of this project evolving?
Well, I can definitely see a world in which human and robots are working together and working as a team, where you have robots that are on the ground doing science and figuring out how to work in these harsh environments. I can also see crew working side by side with robots up in the space capsules, with the robots doing a lot of the menial and kind of boring work to free up the crew for doing other more interesting things. This is definitely breaking new ground. Usually you think of it in terms of robots as a separate entity from humans, but I think it's really when you get the two working together that you have a really good combination for allowing us to go places we haven't been before.
Thanks for joining us, and meet us again on our next Destination Innovation. For more information about NASA's Human Exploration Telerobotics project, please visit nasa.gov/telerobotics.